We are back talking about seasons, and we had just finished talking about the tilt of the Earth is responsible for causing the seasons, not the distance from the sun. And we went through this picture, and we drew on here showing that when we're pointed towards the sun in the northern hemisphere, we have more hours of sunlight than we do of darkness, so it's going to be hotter. In December, the axis is tilted away from the sun, so we have more hours of darkness than we do sunlight. Well, so it's going to be colder. Then on the equinoxes, the axis is tilted at a 90-degree angle, so it's going to be exactly 12 hours of daylight, 12 hours of darkness everywhere. So we talked about that, and we went over our definitions of what a solstice is. Most unequal amount of daylight and darkness, and the equinox was the equal. And when we went back, we had said, remember, that the tilt of the Earth causes two things: the number of hours of sunlight to vary, and also the intensity of the sunlight to vary. So we need to talk about this a little bit more still. So I start with a little example. If the North Pole receives 24 hours of sunlight on the summer solstice, and many days before it, why doesn't all the snow melt? If it's getting 24 hours of sunlight, why doesn't the snow melt? Well, the reason is this intensity of sunlight. And I like this little picture with the flashlight, and I'll do this in class so you can see. But when the sunlight's coming at a direct, intense angle, you have this kind of solid, small, bright, really intense heat. But if it's at an angle, it's going to spread that out. It's less concentrated, less intense. It's going to be less hot. So I put my little thing here. I said the sun isn't very high overhead, so the sunlight that does reach the ground isn't very intense. The lower the angle, the sun's energy is spread out over a larger area, making it not as intense. So we get back to this question about that we were talking about, this intensity idea. And this little picture down here shows what's happening. Let's say this is Dallas. During the summer solstice, the sun is going to go up, it's going to rise a little bit closer to the north. It's going to be directly overhead, beating down on top of you, and then go and set a little bit farther north. So if you go outside on the football field or soccer field in June 21st, the sun is right overhead, just beating down on top of you, feels incredibly hot. Well, what about December 21st? Okay, so jump over here. Let's say you go out to that soccer field or football field at noon again, but on December 21st. The sun isn't up here like it was in this picture. Okay, the sun at noon is down lower. So the angle you can see with the shadow, the angle the sun is coming in at isn't as intense. So at noon on December 21st outside, you're not feeling as hot because it isn't as intense. Then of course on the equinoxes, the sun is going to rise straight in the east and then set straight in the west. And it's not directly right over top of us because it's directly over top of the equator. Okay, it's equal. It's right up over the equator. So for us, it's going to be not quite as hot as summer, not quite as cold as winter. It's, in the middle, the spring and the fall. This one again, just showing you a slide like what we showed before. And again, we can see this angle idea better. This time it's summer on this side. You can see the sun is beating down right on top of us. So you go outside at noon on June 21st, the sun is right overhead, really intense sunlight, really hot. But in winter, it's going down, it's in the southern hemisphere. Okay, we're up here somewhere. The sunlight's going to be at an angle. It's not going to be as intense. It's hitting the Tropic of, these are where the tropics are, the Tropic of Cancer and the Tropic of Capricorn, where they're overhead. At the equinoxes, you can see it's hitting directly right on the equator. Okay? So that, again, is caused by the tilt. So we saw that it causes two things. The tilt causes the number of hours of sunlight to vary. We're getting lots of hours of sunlight and few hours of darkness. And the sunlight is really intense because it's directly overhead. So it's going to be hot. So it's going to be summer for us in the northern hemisphere. Okay, so this is northern hemisphere again. Southern hemisphere, of course, is winter. And you think about that with the Olympics. Okay, whenever they hold the Summer Olympics somewhere south of the equator, they have it kind of at a weird time, usually think. It's like, maybe it's March or something like that. It's like, well, that's not really summer. Well, right. But if they had it in June, that would be dead of winter for the southern hemisphere. So it's things like that you have to kind of think about. If you're saying summer or winter, you have to make sure you know where you're talking about. So the northern hemisphere is where we're talking about. And then just another recap here again, making sure that you realize that summer is not hot because we're closer to the sun. In fact, we're at perihelion during the winter and aphelion during the summer. And I said, luckily for us. So our summer is when we're farthest from the sun. It makes our summers maybe a little bit less hot than they could have been. Our winters are when we're closest to the sun. Maybe it makes our winters a little bit less cool than they could be. The southern hemisphere, of course, is the opposite way. They have winter when we're at aphelion farthest, and they have summer when we're at perihelion at closest. Okay? So the reason we have seasons is the tilt of the Earth. And the Earth's tilt causes the number of hours of daylight and darkness to change throughout the year, and it causes the intensity of the sunlight to change throughout the year.